In this problem, we're asked to find the vertex of a parabola, and the parabola happens to be 2x squared minus 4x minus 1, which is written in general form. To find the vertex, we'll want to write it in standard form, and to do that you need to complete the square. So one of the first things I like to do is change f of x to y, and then we're going to move the constant to the other side of the equation so that we can start completing the square process. So I'm going to add 1 to both sides. And then before you complete the square, the first term on the right hand side has to be just x squared. You can't have a 2 or any other number in front besides 1. So what we're going to do is factor the 2 out. And if you're going to factor the 2 out, you're not only going to take it out of the first term, but you're also going to take it out of the second term. And now we can go ahead and complete the square. And the process is take half of that middle number and then square it. So we get a plus 1 that we're going to add in there. But we really didn't add 1 to the right-hand side. What we really added was 2 times the 1. Since you factored out the 2, you have to multiply it back in to see what you really added to that right side. So if I added 2 to the right, I have to add 2 to the left. So I end up with y plus 3 equals 2 times, and now you made a perfect trinomial square here, so I should be able to factor it into something times itself, and in this case it's going to be x minus 1 times x minus 1. If I condense that down, it becomes x minus 1 squared, or taken twice. And then to finish out the form that we're trying for here, that standard form, I'm going to move the plus 3 back over to the other side by subtracting 3 both sides of the equation. So I end up with y equals 2 times the quantity x minus 1 squared minus 3. And from here, I can locate the vertex, which is positive 1, negative 3. Remember, the h is 1, the k, in this case, negative 3. And then the axis of symmetry, remember, is a vertical line, so it's going to have the equation x equals, and it's going to be the x value of your vertex, so in this case x equals 1. If I wanted to find a y-intercept, I have two options. One is I can go back to the equation that I just came up with and let x equal 0 and then solve for y, or probably something that's a little bit easier is to go back to the original and plug in zeros there and come up with negative 1. Either way, though, you're going to come up with that answer of negative 1, so the y-intercept would be located at the coordinate 0, negative 1.